Hi everyone, my name is Bahar and I'm a PhD student at University of Toronto. In this talk, I'd like to give you an overview of our paper, Knowledge Translation, which is a joint work with Professor Miller, Professor Lyons, and Professor Nargesian. When dealing with knowledge bases, one of the most challenging issues is how to populate a knowledge base with up-to-date ground facts. Knowledge bases can be populated with instances from many different resources. The ones that we are going to look at in this work is structured resources and in particular sharing data between two knowledge bases. Data sharing tasks among knowledge bases generally involves two steps. First, alignment, which is the task of finding a set of correspondences between the source and the target knowledge bases. Second step involves interpreting the set of correspondences collectively to solve a specific data sharing task, for example, data exchange task. The approach introduced in this paper can be categorized under the second step, in which we take a set of correspondences as our input and generate mapping rules that express the relationships between the source and target knowledge bases by interpreting these correspondences collectively, and further enrich them with information that lies within the structure of the source and target knowledge bases. In this work, we create mapping rules that allow data in a source knowledge base to be translated into a target knowledge base, a process called knowledge translation. To give an example that highlights the distinction between the two steps of knowledge sharing, imagine that we have two knowledge bases as follows and given two correspondences, red and blue lines in the picture, that express that concept person in source corresponds to concept person in target, and attribute a work address in source corresponds to address in target. In this case, one can use the red correspondence to generate mapping rules which copies over every person's IRI and make them instances of the concept person in target. And add the blue correspondence to copy over the address value and make it an attribute of a blank office instance in the target. However, in translation, one might also use a set of more enriched mapping rules, which are created by investigating how the elements which are put into correspondence are associated with each other in each knowledge base and whether these associations can also be translated into target. For instance, in this example, we can benefit from interpreting correspondences collectively by trying to preserve the association between the resources they put into correspondence. For instance, here, since a person can be associated with a work address in the source, we might want to suggest mapping rules that associate persons with their work addresses in the target. In addition, here, two persons in the target are associated using a relationship called related. In this case, we want to see if two persons can be associated in the source, and if so, ask the user if they want mapping rules which populates the related property in the target using some of the possible relationships in the source. In this case, we want to see if two persons can be associated in the source, and if so, ask the user if they want mapping rules which populates the related property in the target using some of the possible relationships in the source. The focus of knowledge translation paper is Kensho, which is a tool for automatically generating such mapping rules among two knowledge bases. In this paper, we explain how these mapping rules can be created and how they can be ran. In addition, we have done an extensive evaluation of Kensho to highlight some of its most important benefits and shortcomings. Note that several pioneering approaches have already begun to investigate the automatic generation of such rules. However, what differentiates Kensho from the existing approaches is the way Kensho defines associations, which in turn help Kensho to generate mapping rules even in the presence of a sparse or incomplete set of correspondences among object properties. It can also perform value invention while preserving the proper grouping of data in the source knowledge base. In addition, Kensho uses a set of ranking heuristics to reduce the burden of selecting the best set of mapping rules. Kensho generates executable mapping rules in two steps: semantic association discovery and correspondence interpretation. In semantic discovery step, for each of the knowledge bases, let's look into source for now here. For each aligned concepts, that is concepts which have corresponding concepts in other knowledge base or participate in attribute to attribute correspondences, marked with orange text here, we find a semantic association, which in a nutshell captures the set of aligned nodes that can be in association with them and all the ways that these associations can be formed. We discovered these semantic associations by creating a layer of abstraction over RDFS graph of the knowledge base, and then using that layer to systematically create semantic association for each aligned node. Note that for each semantic association, a query pattern can be created. In correspondence interpretation phase, we pair a semantic association from the source with a semantic association from the target and use a given correspondence to map variables of source and target. Note that for some correspondences, there are multiple ways that this mapping can be done. Each of these ways represents an interpretation of that correspondence. For example, we could map a country an employee was born in to the country of the organization of which she is an alumnus. Or we could map the country of an organization for which she has worked to this target node. In this work, we use several measures of validity which can help reduce the number of ways that each target variable can be mapped to a source variable. Finally, to generate the mapping rules in forms of construct as SPARQL queries, we use the query pattern of source to generate the where clause of the query and use various variable mappings to generate binding statements in the where clause. We use the query pattern of the target semantic association to generate the construct clause of the query. And while creating the construct clause, we create a blank node for each variable which is in the path that connects two other bounded variables. Kensho is the only tool that takes on the task of generating associations for all paths in the knowledge base. So to reduce the burden of selecting the best set of mapping rules, we have proposed 3 new ranking heuristics to rank the final set of valid mappings. We have evaluated the effectiveness and the performance of Kensho using a large number of scenarios. More specifically, we evaluated Kensho on 4 real-world scenarios designed to highlight the role of knowledge translation in different tasks, including tasks which aim to populate an existing knowledge base using an open data corpus. We also performed experiments on 50 synthetic scenarios to evaluate the performance as the complexity of scenarios is systematically increased. This set of scenarios includes settings with over 2,000 concepts, which is more than 3 times greater than the number of concepts in DBpedia. Our results show that Kensho scales well as the knowledge base size increases, with the largest bottleneck being the number of possible interpretation of correspondences. In addition, we have compared Kensho with current approaches using 3 existing benchmarks and included a small case study that showcased the advantage of using Kensho instead of manually creating a set of mapping rules. So to conclude, in this work, we introduced Kensho, a tool that translates knowledge between 2 knowledge bases by generating mapping rules between them. We believe that this is a rich area for future research. For instance, how these automatically generated queries can be further optimized and used to create best set of examples to be shown to the domain expert, how these examples should be presented, and how to incorporate domain experts' feedback, which sometimes might be contradictory or wrong, among many other challenges. Thank you very much for listening.